Hi there, Maple and Chestnut class. I'm so glad that you've decided to have a go at planning and completing a fair test. In this learning video, I'm going to show you step by step how this can be achieved, and I'm also going to draw your attention to some resources which should help you along the way. Okay. When I'm thinking about planning a fair test, my starting point is always variables. By variable, I mean something which can affect the outcome of my investigation. Now, I'm investigating how high the ball bounces. So my variables are things which I think might affect how high the ball will bounce. For example, I think that maybe the size of the ball might affect how high it bounces. I'm thinking that perhaps the way I release the ball, whether I throw it or let it go, might affect how high the ball bounces. I'm thinking that the surface on which I drop the ball might affect how high it bounces. I'm thinking the type of ball might affect how it bounces, and I'm thinking the height from which I drop the ball might affect how high it bounces. So here I've thought up and written down on post-it notes a whole load, a range of different variables which might affect how high the ball bounces. Now, in order to produce a fair test, I'm going to select one of these variables. Okay? And that one variable is going to become the heart, the center of my investigation. It's a thing I'm going to investigate. For example, I might investigate the type of ball. So my question would become, does the type of ball affect how high it bounces? Or I might investigate the surface on which I drop the ball. So my investigation will become, does the surface you drop the ball on affect how high it bounces? I might investigate, does the way you release the ball affect how high it bounces? I might investigate type of ball. I think I'm going to begin with investigating the height at which you drop the ball. So if I just copy that, I can put that same post-it note up there. So my question becomes, does the height at which you drop the ball affect how high the ball bounces? So that variable has now become at the center of my investigation. But my work is not done yet if I want to create a really fair test. In order to create a fair test, as well as picking the one variable which I'm going to change, the one variable which I'm going to investigate, the one variable that sits at the heart of my investigation, I'm going to make sure that all my other variables remain the same. They do not change. So while I will change the height at which I drop the ball, I'm going to make sure the surface on which the ball drops on is always kept the same. I'm going to make sure the size and type of ball are always kept the same. And I'm also going to make sure that the way I release the ball is always kept the same. By changing this variable and keeping this, and this variable the same, I should ensure that I create a fair test. My next step is to move on from the design stage, in theory, into a more practical process. So I need to take this design and show exactly what it would look like in real life. What would this investigation look like? Okay. To do that, I'm going to use a scientific diagram. So my first step is, how many stages, how many steps, how many times am I going to do this investigation? I'm thinking probably 1, 2, 3 times to begin with. See how that goes. Okay. So I'm going to drop the ball and I'm going to use a meter stick to help me to change the height at which I drop the ball. So I'm going to start by thinking about what I'm going to change. So I think on the first one, I think I'm going to drop the ball from 25 centimeters. And I might just record that on there just to help remind me what I'm going to do. The next stage in the investigation, I might drop the ball from 50 centimeters. So let me just pop that on there just to remind me. And the final time, I'm going to drop the ball from 75 centimeters. So let me just jot that down, just to remind. Okay. So you can see there that in my investigation, I've identified that I'm going to change the height at which I drop the ball. I've shown in my diagram that this is the variable I'm going to change. My next step is to think about, well, how can I show that the way I release the ball, the type of the ball, the size of the ball, the surface on which I drop the ball are all kept the same. Let's start with the type and size of the ball. Well, then my diagram shows I've used the same type of ball and the same size ball each time. I could put something on my diagram which could just illustrate and remind me that the surface on which I want to drop it, I think I'm going to use a flat concrete surface. So I'm going to draw a flat concrete surface there, a flat concrete surface there, and a flat concrete surface there. All meant to be the same. You can see they're a little bit wobbly. Try my best. I could then also show, this would help if I wasn't using this silly pad, I'm just going to draw my, oh no. I need something a lot smaller than that. I'm going to just draw my hand. This is a lovely picture of a hand. I'm going to draw my hand there to remind me, can you see that's a hand? To remind me that actually I'm going to release the ball in the same way each time. Okay? So, oh, this is going to be annoying, isn't it? Let me just move that for a second. Look at that, there we go. So I'm going to put that over here as well. I'm going to release it in exactly the same way here. And I'm going to put it up here because I'm going to release it in exactly the same way here. Put that meter stick back over there. Okay. So hopefully now this diagram can show that I'm going to do this investigation 3 times. Once at 25, once at 50, once at 75 centimeters. That's the variable I'm going to change. However, all other variables I'm going to try and keep the same. Same size ball, same type of ball, same method of release, same surface the ball drops on. My last step, which I might like to consider, is how can I improve the accuracy and reliability of my measurements. The way you can do that is to actually not just take the measurement once. You could actually indicate in your plans that you're going to do the same activity 3 times, perhaps, and take an average measurement. You're going to do the activity 3 times, take an average measurement. You're going to do the activity 3 times, and take an average measurement. That would improve the accuracy and then the reliability of your results. Yeah, I've designed my investigation. Brilliant. Before I move on, I just need to make a note for myself about what I'll need to measure. That's quite simple for this one. I need to measure how high the ball bounces. You might like to go into a bit more detail about how you're going to do that and how you're going to ensure the accuracy of that. That's up to you. Next thing I want you to draw your attention to is your prediction. Now, because a prediction is a specific form of scientific writing, I've produced a document to help you recognize exactly what should be included in a year 3 or a year 4 prediction. Okay? It says here that to create a year 3 or 4 prediction, you need to be able to explain what you think will happen using everyday and scientific language, if possible. Also, you need to go on and justify your prediction using your personal experience. Okay, so you're not just taking a random guess, you're saying what you think will happen, why it will happen, and what experience you've had of this in the past. Okay, draw on your experience of bouncing balls. Okay, use that to help predict what will happen. Once you've done your prediction, you can move on. Results. To put it simply, results show in a nice, simple, clear way what happened in your investigation. So you could record them down in a table, or you could think about a more visually interesting way of displaying your results to make it easier for your people who are reading or understanding your investigation to interpret. I suggest, if you can, having a go at using a program like Purple Mash to help you do this. So what I've done is I've already started this process. I've labeled my axes over here. This axis shows how high the ball bounced. This axis showed how high the ball was dropped from, 25, 50, 75. Okay, I've also put a title up there which shows what the whole graph shows. Does the height from which you drop the ball affect how high it bounces? I'm now going to start inputting my data. So let's imagine I did my investigation. When I dropped it from 25 centimeters, it bounced 16 centimeters. Looks like, oh, there we go. But my computer had frozen for a moment. When I dropped it from 50 centimeters, it bounced 31 centimeters. And when I dropped it from 75 centimeters, it bounced 49 centimeters. Okay. Here, I now have a bar graph which shows my results. I've got a little table over here which shows my results, and I've got a bar graph. Because what I've produced is a set of continuous data, that means the areas in between 25 and 1575 also potentially have meaning and understanding as well. I could, if I wanted, present this using a line graph as well. Okay? Be very careful about using line graphs because it can only be used to present continuous data and not discrete data. That's something we can go into when we're back in the classroom. But I'm happy with this graph here. I'm happy with this line graph because I think that actually what I've produced is a set of continuous data. So I'm going to take a little snapshot of that, and I'm going to pop it into my results section. Great. Nothing there. It's a bit big at the moment, but you get the picture. Okay. So there we go. Got my results. That says what happened. Okay. The next stage is to move on and create a conclusion, basically what you found out. Now, again, because this is a formal piece of scientific writing, I'm going to use this really useful document here, which I've attached onto your plans, to see what a conclusion should look like in year 3 and 4. It says here that you should use everyday and scientific vocabulary to spot patterns and trends, select examples which support the generalized statement, right? And apply personal experience and learn scientific vocabulary. So basically, you tell me what patterns you spot, okay, what general trends you can see, and you're trying to explain why this happened. Okay. So as I look at my results, I can see some general trends. Okay, I can see what happens as I increase the height from which the ball. I can see a very clear general trend there. Okay. And then I need to go on to explain in my opinion, on my experience or my scientific knowledge exactly why this happened. Once you've done your conclusion, you can move on to your evaluation. Again, because it's a form of scientific writing, you could use this section down here to help evaluate your investigation. Identify ways in which it was and was not fair. Make suggestions on how to improve fairness. Make suggestions about how to increase the scope of the investigation to make it even larger. So what you're trying to think of is you're trying to think of two main concepts, the idea of accuracy and reliability. Were your results accurate? Did you measure them accurately? Did you take repeated measurements to ensure the accuracy of your measurements? Down here, you're thinking of reliability. This is something a lot to do with fairness. Was your investigation fair? Did you manage the variables? Was your investigation big enough? Okay. Did it have a large enough scope? Could you have measured at more different heights? A meter, 1 meter 25, 1 meter 50, etc., etc. Once you've completed that, you've completed your investigation. Now, when it comes down to it, you can choose the investigation that you want to select. Okay. If you want to do the exact same as me, oh, sorry, these are something completely different. These are from earlier. These are my year 1 and 2 ones. Let me go back here. If you want to investigate the height at which you drop the ball, great. But if you actually want to do something different and investigate the surface on which you drop the ball, or the size of the ball, or the type of ball, or even the way you release the ball, that's totally up to you. Okay? But I'd like you to take this step-by-step approach to creating a fair test. And I'd like you to use the pro forma provided to produce a method and a prediction and a conclusion and an evaluation. If you do that, you'll have a really, really great investigation. Good luck.